which I said is a typical domain that is using this merger technology is microelectronics industry. And why I am naming this microelectronics industry, just not because it's my specialization, but this is one that is driving virtually now the globe to a very, very large extent. The first one I said, these microelectronics industries have used microfabrication for a long, long time. For a long, long time, in the sense that ever since we have started using this fabricating transistors way back in 1948, those days we have micrometers, but later on, whenever we are coming down with the integrated circuit, we use micrometer technologies. When you use Pentium 4, by that time we are using 180 nanometers and 130 nanometer technology. That is almost 20 years back. Now you know that you have wonderful laptops that uses i5, i7. Your desktops are wonderful. And if you ask that what is the technology they're using a much smaller technology, and we call that nanotechnology because we are using a technology that uses the length of your MOSFET or any other device, because there's the MOSFET is being now it is being challenged, the silicon is being challenged. We are using FinFET and other kinds of devices. So now we are using nanofabrication. So this micro and nano fabrication have been streamlined by the microelectronics industry, but that was one part of the story that the electronics industry have used that. But today, if you look at all other industries are now also using the same technology for their mechanical small products. If you look at the 3D printing and then the products that is coming out, any product that is coming out, because if you say that you have to go with an assembly line means you take an example. Suppose you say that you want to come up with a dishwasher, and dishwasher you would say that there are different components, and this mechanical fabrication has to be done, but that are using this micro and nano fabrication. So that is why I said a typical domain that is using both micro fabrication and nano fabrication. And it's not electronics, but the other people are using this. So whether it is mechanical machining, electrochemical machining, or lithographic machining. So we are saying that machining, all these are adjectives to that, mechanical, electrochemical, or lithographic, and that you would look at are using both. Now coming to the fact that how we are going to handle, because when I said that the different toolbox, I have used other than material science, for which I gave you a couple of different examples. One is battery and so on and so forth. I said computing and analytics. So that's more or less now we are using a word which we call is digitalization. So that's the new norm. Adapting to new normal requires a digital mindset. So everything that we are nowadays saying, that people will say that we are now looking at a digital mindset. And digitalization changes everything. And yes, the answer is absolutely yes. Digitalization changes everything. But as we proceed, we will try to understand this digitalization, how it changes everything. But more or less, all of us are using it in different places, and that's what is, also the government is looking for. It's not that you and me looking for, but also the government which is looking for that. So that is what is the point. Now these are the typical examples of techno-fusion for R&D, because that's what the interest for the most people who are in academics or R&D lab. And also you have to look at the first thing I wrote is smart cities and IoT. I gave this particular example. You would say that smart cities and IoT because in our country we make a noise that smart city, smart city, smart city. In Odisha, we have two. One we call Bhubaneswar is one of the smart city. We are not completely smart by today, but we hope that we will become a smart city. And if we want to go for smart city, I will take up all these things individually, at least the majority of these stuff, and where this fusion is happening. And that's using this IoT significantly, Internet of Things. The second one I wrote is AI and ML, artificial intelligence and machine learning, and that's being used by everybody. See, don't take a confusion that that's being used by you, me, and like that, but it's being used by almost everybody. And then I said health, medicine, and life science technology. So health, medicine, and life science technology. And if I now combine this AI, ML, and health, medicine, all these things, I'll give you another small example which uses this. And this becomes an issue. So imagine that a particular company manufactures a tablet. Let's take the example of, say, Dr. Reddy's lab. Okay? Or for that matter, take the example of Ranbaxy. They manufacture a specific quantity of medicine for a. So what they normally do, they have conducted research. They have observed that this particular drug would be useful. So now they gave it to the fabricator, because the every fabrication cannot take place inside a particular lab. So when the fabrication takes place. Now just look at it. Okay. And here what I am saying, that imagine that this particular company says manufacture 1 million tablets for me. Now the fabricator fabricates 10 million tablets for that. Now you say that what these 10 millions are doing. So what is said that you take this 1 million, because I have ordered for 1 million. Say Ranbaxy ordered for 1 million tablets. The other 9 millions are left with the fabricator. Now he can play around. He will give a different nomenclature and supply it to someone else. And you must realize that whenever we do any industry, the fast copy itself is very expensive. But later on, we only use the material cost. So the original cost has been already recovered because the company has paid for that. Ranbaxy has already paid for that. And now in the market, I have other 9 million tablets which I am selling it to a company called XYZ. I am not deliberately trying to name it, but yes, XYZ, but at a much cheaper cost. Now you'll find out who is the loser. Now the whole point is that the Ranbaxy is the loser who conducted the entire research, came up with a wonderful drug, but before they supply to the market, because of the foul play by this particular company, they are now trying to do it, selling it into the market. So that we have to protect. So that is what is being done through this blockchain technology. So that is for the security aspects. So we are applying it to the medicine distribution because that blockchain technology will look at from the fabricator to the major company, then it supplies to the wholesaler, to the retailer, to the person. And the whole thing is now, the blockchain will now try to, that uses this intelligent techniques, artificial intelligence, machine learning, deep learning, and all these intelligent techniques, they will use this and they will use it for controlling these drugs. And imagine the same company who has fabricated, suppose the life period of this particular drug is 3 years. Now he can play one more mischief by saying that within 3 years he could not sell it, this 9 million, and after the 4th year also he's selling it, putting a stamp over there that yes, the medicine is still valid. And if the medicine is still valid, then it goes to the market in the name of Ranbaxy, and Ranbaxy gets a bad name. So therefore, this blockchain technology is playing an important role for saving us from all these stuffs. So that is why I said that although we are saying that technofusion, this artificial intelligence and this machine learning is virtually being used in so many, areas. By saying and going by a webinar doesn't really help us out. So that is why I said that there are two other requirements. One, we say that there is a knowledge center. I mean, knowledge center means what? You'll have to open it up just like, yeah, now I'm showing domain slide.
Yes, sir. Yes, sir. Now it is visible. Okay, sir.
Yeah, there could be a network issue.
Yes, exactly. Okay, sir. Thank you, sir. Sorry, sir. Sorry.
No, it's fine.
Okay.
So what I said, if you go back to 1998, prior to 1998 in India, we had only two cars. One is Ambassador, that is called Hindustan Automobiles. That has almost become extinct, except a few that I find on Kolkata roads or Mumbai roads used as taxis, but otherwise very rarely you will find. In some of the typical offices also they are using still that Ambassador car. And there was a Premier Padmini or Premier Automobile was using that car. And by that time there came the Maruti 800. So these were the few cars those were available in India. In 1998, there are 4 cars which were launched in India. And these are Santro from Hyundai. Then there is a Matiz from Dev. Then our own Tata company launched Indica. And then this Maruti also launched its another model called J. What was the revolutionary change was, for the first time in the history, in the Indian context, they used a computer inside it. Okay. Until that time, there was no computer was ever used in the Indian cars. I mean, Maruti 800 or this Ambassador or Premier Automobiles, they never used that. They might have used on a later date, but till that 1998, they never used it. And in that particular year, they used this one. All these 4 cars, whether it is Santro or Matiz or Indica, or for that matter, J. And they used 8-bit, 12-bit, 16-bit, different kind of microcontrollers. You would say that why on earth they used it? They used it for 2 purposes, because till that particular point, you know that the car selling in India was very less, but the Indian economy has been improving steadily past 1991. And people were in a position to buy cars. So when they purchased cars, they wanted better quality cars. And when they wanted better quality cars, they always looked for the fuel efficiency. So the right kind of air fuel mixture has to come up, and that was possible provided you put a small computer inside it. A small computer means don't think of a big one, just a small chip. It's actually, it was a microcontroller. And that microcontroller was taking care that what should be the right ratio of the air to fuel, so that you achieve the maximum efficiency with all the possible resources. Possible resources, I mean, that because whenever I say that your fuel efficiency, it also depends a lot of things by the driver. How exactly he is driving. He is not driving at the rated speed of 50, 60 kilometers per hour all the time. He is driving in first gear or second gear. And what is the tire condition? What is the road condition? So several factors are there. But with all that, if there is an optimization required, that was only done by the computer. that the second stringent requirement at that point of time was the pollution. And Delhi was getting polluted, so the government thought that we cannot go ahead with this kind of pollution. Even today, we are also facing similar issues as regards to the pollution. So they say that it must be Euro compliant 2.0, 3.0. So the pollution has to be controlled. And if the pollution has to be controlled, this computer will take care of saying it that what is the right kind of fuel and air. So the pollution remains within a specified limit. Okay. So this is just one example. As I said, that the examples should be many. So now the next one I say is aerospace. Aerospace is, that it's a typical engineering that uses mechanical, electrical, and many other, and finally it's finding its own identity. I must say, a very advanced technology that is using. Now talking about industrial machinery. There are different kinds of machinery where we are using these fusion technologies. Then Industry 4.0. For this, it is the most important because we are saying that we are once upon a time just a fabrication industry, and a fabrication industry is good enough. But that's what is not today. We'll have a lot of electronics control and a lot of IoT compliance so that the person understands. So what I mean to say that if I have got a washing machine in my home, the health of the washing machine must be known to the company who has sold it to me, whether it is LG or Samsung or it is Bose or IIC. And if they find that there is a difficulty, then what they have to do. Similarly, in the Industry 4.0, I don't want my plant to be down even for a few hours. So if I go to Rourkela Steel Plant, as I have already told, that I have got 1,000 induction machine lined up, if I find that a particular section fails, then I am in trouble. Because see, there are different sections that I have in Rourkela Steel Plant. I get raw materials, then I have to do the melting, the blast furnace, then I have to create sheets with the hot rolling mill and the cold rolling mill. And if I have to go to the hot rolling mill and cold rolling mill, then the thin sheets and the thicks of the right kind of thickness has to come out. But if there is a problem now, the whole scenario that happens, that the plant is down. But that is what is not intended for. If I am down with my Rourkela Steel Plant for a few hours, then I am losing crores of rupees. I mean, it becomes, declared inefficient tomorrow. So that is what is not the desire. And if that is what is not the desire, then how do I manage it? The point is that you have to get it connected through IoT. So the experts are sitting elsewhere and they will immediately provide you the solution that what to do and how to handle it. Okay, it's a matter of a few hours. But if it is something down, it will definitely take hours to get it done. But not that you hire an engineer, German guy comes over here. The Rourkela Steel Plant is a German collaboration, and then he rectifies it, and you are down with the plant for 10 days. Then you are gone. I mean, that's what is not acceptable. Similarly, now we look at digital factories. Then we say that shipbuilding, industrial automation, mining, energy, process engineering, all these areas we find that yes, we are using this fusion engineering, fusion technology. Then I'm just putting this IoT lab because we have been saying in the past one, the smart cities and IoT. In the IoT lab, when I say, then we are saying that we are looking at these are the applications that were there. And if you look at this, then you will realize that virtually everything is covered in this one. I said energy management, smart cities, wind power, power, gas, power generation services, mobility, that is your automated, building technology, and then healthcare, process industries and drives, that is Rourkela Steel Plant and similar, digital factory, So we are virtually covering almost every industry by using this particular IoT. So that is what is now summarized over here. Digitalization changes the workplace. Digital skills are standard requirements as are analytics and problem solving. Innovation becomes everyone's job. Okay. Manual labor and routine tasks decline. Analytics dominate decision making. Path of human cloud and gates. Now, what has been the complaint over the last decade or so? Because I'm just trying to put it, because the government is also thinking in a very similar line. They say that with all this digitization, all this the third point I have written, manual labor and routine tasks decline. And so, in a country like India, which is a developing country, and what would people eat? They will become jobless. The answer is no. It's not that they are becoming jobless. See, the only thing that has changed is that we are not trying to look at the manual labor and the typical. Yes, manual labor do decline, routine tasks do decline, but at the same time, we require people with a different skill set. We require people with analytics domain, we require people with computing knowledge, etc., etc. And that is why I have written this last line, path of human cloud and gates, in the sense that we have a set of skill set people, and that you can create as a human cloud, just not for the human, the cloud computing that we get. Cloud computing is, yes, you have tools in the cloud, you use that, do the computing. Similarly, we say that if you have experts elsewhere, we use that. That is what we talk about. We say that human clouds. This is just IoT. Please note that this one I have copied it directly from the internet. So this is nothing mine. So that is the reason I have put it kamsak.org. And this is a standard one. You will find out the moment you try to find out IoT. But what is interesting about this is that you just look at this one and you find that there are cars. Or vehicles that I'm talking about, then we find the different kinds of vehicles, cycles, etc., aeroplanes, and so on and so forth. You look at this symbol of Wi-Fi and the internet connection. Then I've showed different kinds of connectivity over here. Then we show simple stuffs like this, and we say that they are being interconnected. Okay, so that is what is the IoT that I'm now putting it. Internet of Things refer to fast-growing network of what? These are things or objects, but at the same time, that are able to collect or exchange data. Data could be raw data, but when I say information, that's the actually become useful information. And in real time, using embedded sensor, because that's many times we are interested about the things happening in real time. Just for example, I tell the Raurkela is a city not very good as regards to the medical facilities. We have a patient at IGS. We have already admitted him. But what I can look at it, that now suppose I am conducting his ECG. Then we have a doctor at IGF. He finds out something, but he's not very sure. So what he says that he gets connected to a doctor at AIIMS Delhi or Apollo Hyderabad. So now this information that it is happening is connected directly, and he gets the required advice immediately. So that is why I said that it is happening in real time using embedded sensors. I've given some examples over here: thermostats, cars, lights, refrigerators. And because these are some of the examples which, if I tell, most of us understand and easily, but there will be more complicated examples. But let us go into that. And see the IoT applications, I said smart home, this Amazon Echo or Google Home. Many of us use this Amazon Echo. and that's an IoT application. So because we have a habit of asking Alexa a question, Alexa, what is the word? Reply. And so how does Alexa replies this? Yes, there is a speaker so it speaks out, but where does it get the information? The information it gets from the internet. So that is what I'm saying that Alexa is capable of doing almost everything. You ask to sing a Kishore Kumar song, it is. And similarly, this IoT application, I'll say that it is the Fitbit. Okay. Then we have smart cities, villages, country, region, because we are using this word smart city too often. So that is why I would say that smart city, but we can use this word villages, country, or religion. And I have given an example Barcelona because this is a very commonly used example. All the football lovers understand what is Barcelona. So yes, that was the first ever smart city across the globe. Then connected cars. Connected cars today means all the information goes to the traffic controller. Also, it goes to the smart grid. Is there any specific issue? No, because there are lots of sounds coming up, so actually getting disturbed. So and smart grid. So these are again pictorially representing that the same thing, whether Fitbit or a smart healthcare or your appliances at home. And why I have given this particular slide is to look at the number of devices that's being used. 75 billion of IoT devices by 2025, another 3 years, but that is how it is growing. And look at the revenue growth. It is really growing up, and so therefore, and now, what are the components of this IoT? We say sensors, and then connectivity, and then data processing and user interface. And everything, this all combined to come up with already a fusion, and this will again be fused with the, or integrate with all other kinds of technology. And there are a couple of issues with this one, as I said, power and security. Security, I have already given an example saying that how a medical company is handling this issue while handling the tablets. And that is why we said that it misunderstood and misconfigured. IoT, although wonderful, will pose risk to our data privacy and safety. If understood and secured, IoT will enhance communications, lifestyle, and delivery of services. So the moral is that IoT is wonderful, but provided you use it properly. Now coming to the smart cities, and the smart cities, people are saying that 70% of people will live by the year 2050. And this is what I am looking at in a smart city or a smart village. Smart farming, education, tourism, disaster management, governance, transportation, healthcare, renewable energy, pollution control. So this could be used also in smart cities, not that the smart city is not doing it. I have just given this example because I have used it in one of my research papers.
Sorry, sir.
Yes.
Sir, our second section from 11:30.
No, I know your second section from 11. I am left with 7 minutes, although we started delay. I will wind up by 11:30, sir.
Thank you, sir. Sorry, sir. Sorry. Okay, sir. Thank you.
So this is what is a smart village. And as I said, that this requires energy harvesting and security by design. Security is another important part. Harvesting of energy means whether you are doing it from this, the regular energy sources, that is why I told about the batteries, but also by the renewables like photovoltaics or all others. And AI and ML, artificial intelligence and machine learning, well, I have already told you the examples. So the whole thing is that artificial intelligence, or for that matter, any intelligent technique will do the analysis, interpretation, and solve problems. So this will give us a better solution for vast amount of unstructured data. This one I will not put it further because you watch more films than me. And what I said that we use sound, video, and graphics at spell. But what I said that it finds application where architecture, health, and entertainment, and we can experience the same by visiting Disney World and Universal Studios, and you will say that I'm putting something from USA. But don't worry too much. You have an access to these things through your different platforms, so you can do this. And here we say that health, medicine, and life science, because many times people all the time say that we conduct research for our own gain, but please do try to understand we conduct research for our own gain. Absolutely correct. If I have to survive as a faculty, then I have to conduct research. But we do also for the society brain implants that would facilitate a paralyzed person to communicate. We here have fabricated a gadget that facilitates a deaf and dumb person to communicate. And remember, me and my students got excited after seeing the movie Khamoshi, where Nana Patekar was unable to talk, but Manisha was the interpreter. But side by side, we could do it that this gestures could be translated into images and images could be translated to voices. So these are the points. And Industry 4.0 is the new norm. So that is why we are looking at the smart manufacturing today. And now this is what is the finally I'm talking the challenges. One technology for one industry no longer applies. I mean, I cannot say that I am doing this. So that when that was happening, then it was breakthrough driven. People are waiting for a breakthrough. But this is, and semiconductor replaced, this is also breakthrough. Semiconductor replaced vacuum tube, CD DVD replaced record album. But this is no longer possible because, and these are the companies that who have adopted this techno fusion. Nippon and a few Japanese companies, they have adopted optical fibers, and because of optical fibers, we have survived today. Even if I'm talking to you today, that's because of this optical fibers. Then this CNC machine doing wonders as regards to this manufacturing, and originally it was by Fanuc. And SARC is the company which did display technologies. And originally they were an electronics company, but they are doing this. I remember when I was a BTech student, in my early days we were using this LED calculators, but later on the SARC came up with this LCD display, and today's market is 38% of the entire globe. So whoever have used this techno-fusion, they have done wonders. So now the R&D agenda, market drives R&D agenda, not the other way. The R&D will not drive the market, and this is customer wants, market drives. Customer wants will be taken up by the companies, and that will drive it. So now, however, we'll have to keep our eyes and ears open for innovations. We'll have to, I mean, we will have to look at the patents and everything, and required. This has happened in every place, every company. Whenever they are trying to do it, they have done it. The one example was that LG was trying to copy the washing machine by Samsung. Samsung came up with neuro fuzzy controller based washing machine, and LG did a reverse engineering by buying it, breaking it, trying to find it out, and they found that it is wonderful, and then they did it by chaos funds. And companies' research investment were to be done, whether it is only in the core technologies or in the combination, that has to be done. And now the question comes, and please don't term me as a politician, but the whole point is that whenever I have said, then people might have reacted that whether I'm only talking about USA and Japan. No, the answer is not. I said make in India. Make in India will have to do it. And the only thing is that government needs to support, and that is what is happening. The next one is Atmanirbhar Bharat. Your next speaker is from MSME, so you would handle that in a much better. So if whenever we are looking at the Atmanirbhar Bharat Abhiyan and this Make in India, the only thing is that how do we handle? We say study in India. This is a program where we are bringing in foreign students to our country. To the NITs, we have brought in many foreign students. So these all things, if we look at it a sincere approach, we will be able to do it in our country. But we must have a positive attitude. So now my conclusions, techno-fusion will play an increasingly important role in the product development. That's a must. Efforts won't be limited to fab industries, rather sectors. Sectors means, as I said already, mechanical, electronics, computer, everybody has to join hands together, material science, and that is what the conclusion is, that the cross R&D is the byproduct. So I haven't given a long list of references, except that I have talked about a couple of papers where we have handled similar issues. Both are my students' own research paper. One is IEEE Consumer Electronics Magazine, another is Sustainable IoT, Sustainable Computing. I think I have been able to complete by 11:30. Thank you, Dr. Naik.
Thank you, sir.
I will sort of stop here, but as I said that because we started little late, so that is why I had to
No, sir. Sir, actually,
No, that's all fine.
3 hours and actually, it's the problem of also the data plan. What will we tell that?
Dr. Naik, I understand. Again, people
Yes,
would
sir.
lose patience if you say
Yes, sir.
that listen, because listening is
Thank
not
you.
that an easy task.
Thank you, sir.
So-
We have already completed it in schedule. Thank you.
But what I suggest is that if there are questions, please do copy it and drop me through a mail.
Yes, sir.
My mail ID will be available with you guys. Otherwise, it is kkm@nitrkl.ac.in. In my website, it's kkm at nitrkl.ac.in. I don't know, it is taking something else.
Now I'm requesting Professor Pratibha Sthia, Assistant Professor, Department of Mechanical Engineering, to present both of them.
Well, moving towards the vote of thanks, I, Pratibha Sthia, on behalf of Synergy Institute of Technology and the entire fraternity of the institution, first of all, extend my most sincere thanks to the Almighty God for making today's event a resounding one.
So, Dr. Naik, I think you can bring all the questions together and send me through a mail so that I can answer to that if it is there.
Yes, sir. Yes, sir.
Since the next speaker is already there, I hope that I should leave this place and maybe Dr. Padi can start.
Yes, sir. Now I'm requesting Mr. Pratibha Sthia, Assistant Professor, Mechanical Engineering Department, to present both of them.
Nothing is audible.
Ramesh sir, you are not audible.
Ramesh. Ramesh.
Kuntiya sir, you are not audible.
Am I audible?
Yes, yes.
Yes, now you are audible.
Hello. Invite our keynote speaker, keynote speaker, Professor. Hello. Am I audible, sir?
Now
Yes,
you are
sir.
audible. Ramesh sir, now you are audible.
Yes, sir.
Video. Hello. Hello.
Yes, sir. You are audible. You are audible, sir.
Okay. So, should I start?
Very no, sir. Actually, very good morning to the respected speaker, Honorable Chairman, sir, Principal Ma'am, Director, sir, all the teachers, research scholars, students, everyone present here. With great pleasure, I am Dr. Ramesh Chandra Naik, Professor and Head Mechanical Engineering Department and President IIC of Synergy Institute of Technology, Bhubaneswar. Welcome you all to this impact lecture in collaboration with MOE's Innovation Cell, Government of India. Institutions Innovation Council, established at higher education institutes, helps in planning and organizing round-the-year activities in the area of innovation, entrepreneurship, and IPR to motivate students and faculties to pursue innovation and startup during their academy. On this section, that the topic is importance of R&D to innovation. And today we are deeply honored and privileged having the keynote speaker, Professor Dr. Poedar. He is the coordinator, IIPC AICT Government of India, co-coordinator, BIMSME Government of India, National Design Consultant, MSME Government of India, ex-director from Chairman Research and Development, High-Tech Group of Institutions. He has obtained his PhD from IIT Kharagpur in 2007. He has published 65 numbers of research papers in national and international journals. He has developed more than 30 numbers of products. He has undertaken 20 number of research products. He is the consultant in NID Ahmedabad, PG Tech Private Limited, NALCO, PIL Chennai, PEL Bangalore, Navabharat Ventures. Synergy Institute of Technology Bhubaneswar was established in the year 2009 under our guiding luminary Sri Vinod Das, Chairman and Managing Trustee, Shivani Educational Charitable Trust. He is the architect behind all the success and development of the team. To all participants, please mute your video and audio. There will be a question and answer section at the end of the presentation. So you may put your questions in the chat box and that will be answered by our speaker. At the end of section, a link for feedback and another link for assignment will provide by us. So you all are requested to fill the feedback form and answer the assignment. The topic is a very interesting and useful for all categories. Now I am requesting Professor Dr. Poridhar Padi sir. Sir, please continue.
Okay, thank you, Dr. Ramesh. Am I audible to everybody?
Yes, sir. Yes, sir. Yes, sir. You are audible.
Okay. So, good morning to everybody, all the participants present over here. So, the topic is very interested, and this topic is the importance of R&D to innovations. So, why I am saying the topic is very interesting, because the research and development leads to innovation. Once research and development happens, then innovation will start, means idea will start, then idea will be prototype, then we can go for commercialization and we will get a business. So, sorry. The second. Yeah, actually, let me speak about the background. In simple way, we can say research and innovation plays an essential role in triggering smart and sustainable growth and job creation. So, research and development as well as innovation, it will create a smart and sustainable growth. Sustainable growth, so and ultimately it will create jobs. So by producing new knowledge, research is central to developing new and innovative products, processes and services, which enable higher productivity, industrial competitiveness, and ultimately prosperity. So if we distinguish between research and development and innovation, where we can say research development turns money into knowledge. Whatever money we are spending on a research and development, it will convert to knowledge. And finally, innovation is the process of creating business out of this knowledge. Whatever knowledge we'll get by doing research as well as development, that knowledge later on it can convert to a business through innovation. So now let us discuss about the pathways of research to innovation. What are the pathways of research to innovation? The benefits of scientific research, particularly basic research, includes not only innovation but also contribution to a trained workforce and to the infrastructure that enables further research and the use of scientific discoveries. It is impossible to predict all of the outcomes or benefits to which basic research might lead. It is equally impossible to predict all the types of research knowledge that will contribute to the future transformative innovation. So here let me discuss, actually whatever research we are doing, the outcome finally comes for a business, because from the research we can, I will give you later on, I will give you some examples, some case study also I will show you in next stages. And now, if maintaining the level of preparedness that will allow in our country to benefit from discoveries made elsewhere is essential. As an actually now here here keeping research for a sustainable way, we are going to we are giving some examples here, like research on zero concept sustainability. Zero concept means zero concept for sustainability. So I will give some examples here later on. So zero concept means first pollution level which creates human health hazards. So we have to go for a zero pollution for which research is required, and we have to identify the problems and how the pollutions are coming, that we have to each and every step we have to identify, then we will go for research, then we will develop products to prevent pollutions. Similarly, zero energy crisis, because now everywhere there is a shortage of energy. In a rural area there are more shortage of energy, so we have to design in such a way that the energy system we have to design in such a way that there should not be any energy crisis. Zero waste, because starting from municipality, house, everywhere, there is a plenty of waste which you can utilize and you can convert all the waste into zero. Then zero non-hygienic food, because whatever food we are taking nowadays in agriculture, whatever way we are generating agriculture food, whatever maybe, all are inhygienic. So people are suffering because of inhygienic food. People are suffering from diseases, and we have to plan in such a way that we have to design our research in such a way that people should not suffer from any diseases. So now in every country there are huge number of unemployment youths are there. So we have to create such an environment, and we have to create so much jobs for them, so much employment opportunities for them, where we will get zero unemployment. So now if you consider the agriculture also, then zero inorganic. I mean, now everywhere in agriculture, inorganic food people are generating, farmers are generating because of the chemical pesticides and fertilizers. So we have to keep complete organic. We have to avoid the chemical and other especially chemical fertilizers to make it organic completely. So that's why I put here zero inorganic. Pesticide also there. Pesticide also, inorganic pesticide we are throwing into the land, that we have to keep it zero, for which research is also required. Zero on non-skill development. Actually, whatever people are there available, lot of people maximum people are not skilled at all. So we have to create in such a way that, or we have to train the people in such a way that there should not be any non-skilled person in the society. Zero material wastage. During processing, lot of wastages we are creating. So we have to create in such a process, and we have to research in such a way that there should not be any wastage of material. And process loss also we have to keep it zero. And manpower, because nowadays you will find lot of manpower are moving here and there. There is no proper utilization of manpower, for which we need we should make the manpower, we should utilize the manpower in such a way that there should not be any manpower lost. So water loss. Similarly, there are so many other items are there which you can make it zero, so that we will get a complete sustainable society. So some of the problems I am identifying here. Suppose before going to the fact, we have identified some problems where I worked myself agriculture. In agriculture, you will find the current days agriculture are unsustainable process which causes deadly environment like health, global warming, etc. So everywhere, especially in India, the agriculture practices, whatever is going on, is unsustainable. Food, whatever food we are getting out of agriculture, since it is unsustainable, we are getting unhygienic food because of the use of inorganic pesticide and imbalanced system. Energy, insufficient and unsustainable energy. We are not using our we are not using at all any green energy, even green energy like solar energy and non-renewable energy. In maximum case, we are using unsustainable, unconventional energy. Health, because the health is also similar way we are facing health system which is deteriorating, and because there is no public health system, livelihood also affecting in rural areas. Women are not getting job, women are facing problem, so no opportunity for rural people. Waste everywhere, full of garbage, no proper utilization system. You might be seen in municipality, in house also, we are not utilizing our waste properly. Manufacturing, there are very less, you can say negligible MSME, micro, small, medium enterprises, which are present in our country. If you compare with the China and other countries like Taiwan, even Vietnam also, you will find every house they are having some micro industry. But in India, we are not getting any micro industry. Very little amount of industries are there, for which employment is also coming huge, unemployment. So I'll give one example. So when China started the MSME industry, by that time why China is capturing Indian market completely? Because at the beginning China sold all the commodities, all their manufacturing goods in India with loss also. So when we got in habituated in getting the China products, now whatever our India government will plan, still we cannot avoid Chinese product, because in China every house they have a small scale and medium scale, even small scale industry. All type of product they are manufacturing, and for which they are leading the whole world. Employment also nowadays, you might be seen, it is declining day by day. Then I am giving no, it's come. So education also, our education system in India also not systematic education compared to other countries, and it is like biased. And now I'm going to give one example how research is coming to innovation. So here one problem I am citing. Actually, it is a livelihood problem where rural women, especially tribal women, are spending 1460 billion tons of residue per year in burning. So 1.5 billion women depend on livelihood on traditional cooking stove, and because of this traditional cooking, 3 million premature death occurs every time. So generally what happens, women spend 370 hours per year for collecting the firewood, going to jungle, by which they are going for deforestation. And government is also restricting them. Still government is not successful. Though Ujala scheme also implemented, still government is not able to restrict all tribal women or any women going to the forest, cutting the trees, and for which environment is affecting very well. So this is a problem. So for this problem, we have to carry out the research. How, in what way research is helpful to solve their problem. So this way research, because research we have to make in such a research that the because the women or people should cook at their home. Ujala scheme is giving gas to them, but because due to the lack of their knowledge and lack of their some problems and even lack of safety, they are not able to operate the gas in their house. And there is a danger situation anytime because of low roof height, there may be some problem in catching the fire of the roof. So here what we have to do, whatever wastage available, means agro waste, especially agro waste is available, we have to carry out the research how those agro waste can be utilized for a combustion system, for a combustion purpose, so that we can give that combustion system to each and every house house in rural area in India, so that they can get their livelihood, or they can cook easily. They will not depend on the Ujala scheme or any gas scheme or any electric heater scheme. And this way, whatever research is the combustion system. Combustion system is chemical. It is a chemical reaction system, combustion. So here research, because of the research, the combustion is a science. We have to carry out the combustion science, and we have to gather the knowledge from the combustion science. So after reading the combustion science, we have to design a system where the combustion can be taken place without even a single traces of smoke, so that according to the knowledge, we have to develop a prototype product. So after getting the prototype product, what we are doing, we are going to commercialize that product, then we will get the business. So this innovative, that idea is the innovation, and combustion process is a research. And there in combustion process, we have to study the air circulation, its a fuel property, air property, and combustion systems, flow system, even computational fluid dynamics also we have to study in detail, so that the combustion should be completely non-smoke combustion system, where perfect combustion will take place. That means no carbon monoxide will come, except a few traces of carbon dioxide, which can also be trapped by a system. That system is called membrane system. Through membrane, you can collect the carbon dioxide because no carbon monoxide is there. So taking those carbon dioxide, we can utilize it later on. That where I am going to discuss in next slide. So this is research. Research achievement through our innovation. We did some research achievement through our innovation, and because we will go for research, unless we innovate that, we will not get any product. Neither will get any product nor any business. So the following areas we have worked in: agriculture, energy, food, health. So many areas we have worked, and out of so many areas, some areas I am showing here. So in agriculture, we are producing biochar. Biochar, we have developed a special technique to produce biochar, or special innovation to produce biochar. Biochar is nothing but the organic carbon. So once you get the organic carbon, you will take this organic carbon and amend with the soil. That means the ratio is for 1 acre of land, you will put 10 2.5 ton of organic carbon mixed with the soil of 1 acre of land. Then for a period of 10 years, you will get complete organic of the soil. No need of, it may be inorganic previously, but after amending the biochar with the soil for a complete period of 10 years, you will get organic. So here also research darkar. Research is necessary. How? Because of research, when you came to know that the from any information, not now in any information right now, in future also, in a past also, our our generations, past generations, they were using this organic biochar by that time. So taking those knowledge and by doing research, we came for came for innovation, for which idea came. Then because of this idea, we developed a technique. We developed a reactor where we can produce biochar, and after getting the product biochar, we are going to get the organic carbon, and using those organic carbon, we can get our agriculture organic. So while preparing this biochar, we'll get another 2 products also simultaneously. That product is bio oil. So bio oil can be converted to biodiesel after distillation. Also, same bio oil can be used or can be applied for health benefits also. So one more product is also there, that is China gas, which is nothing but the substitute of LPG. But in China gas, the calorific value is compared to LPG is very less. So if LPG is 7,000 kilocalorie per kg, in China gas you will get 3,000 to 4,000 kilocalorie per kg. But this China gas calorific can be increased by you doing some research. Also research that innovation cannot be done without any research. So research is the first, innovation will come next. So similarly, another agriculture problem we are solving, like agro waste, we are creating bio waste pellet for cooking. Plant enzyme also we are making for from waste, whatever plant wastes are there, even vegetable wastes are there. From there we are producing plant enzyme for increasing the plant growth. So plant growth promoters can also be obtained by utilizing MSW, that municipality solid waste. And besides that, we have developed a targeted pesticide delivery system where, because you see, while delivering the pesticide to the agricultural land, whether by manual or even nowadays people are using drone. So 90% pesticide is going on waste. 90%. Maybe 10% pesticide may be useful for killing the bacteria, killing the pests. So to avoid all these things, to save 90% of pesticide, we have developed a targeted pesticide delivery system wherever the pests are there, wherever the insects are there, or wherever the pupas are there or larvas are there, only those part will be killed by making that target and spraying the pesticide at that particular point. So this is also necessary, and this also needs research, because keeping targeted means we have to use IoT device we have to use and keep the things as a target, and for that also we may need microscope, and so many items are there. So that at this particular speech we cannot describe details, And if anybody wants, they can ask me they can meet me anytime and I can explain to them. So nanonutrients is another nutrients which even for a human being nutrition is required. For agriculture also nutritions are they required. So micronutrients, nowadays people are using micronutrients, like there are 16 nutrients present in agriculture. And those 16 nutrients, like some minerals are there, zinc, molybdenum, so many minerals are there. But those minerals can be converted to nano, where if you use nano minerals compared to micro mineral, minerals consumption will be very, very less. So also for plant to take nano nutrients compared to the micronutrients is very less. Means nanonutrients consumption will be very less. And by that way, the effectiveness of the nano plants taking nanonutrients will be more. So like energy, zero smoke stove for cooking, that and catalytic biomass power plant also we have developed. Micro hydro power plant also we worked, because wherever there is a little bit of water from any waterfall is falling, so taking that potential energy we can convert to kinetic energy, and we can set a small hydro power plant, and which can give, if not throughout the year, but for a period of few seasons, it can provide power. So waste energy recycling, there are some methods. So that means waste heat recovery. Waste heat recovery in industry, there are during any combustion system, any thermal power plant, whatever it may be, thermal power plant, it may be any food processing, it may be any type of plant where the thermal energy is huge consumptions are there. So in that case, what we can use, there is a system, we can use that system to utilize that heat, excess heat than the requirement. We can convert those excess heat to energy. So for that, there is a system like TEG, thermoelectric generator. So thermoelectric generator now people already started using, and this thermoelectric generator came through research, and because of non thermoelectric generator, I think you might be knowing all these things, like it is like some N type or P type or any junction. If you join together, then you can connect with a higher source for higher thermal energy there. Then connect to cooler part. It is source and sink. Then in between source to sink, whatever change of temperature will be there, that change of temperature will be converted to electrical energy. That means waste heat recovery system is possible. Similarly, biosolar energy. Biosolar energy is a very new concept where we can use this biosolar energy, means bioelectrolyte. We have to convert those bioelectrolyte into solar energy. Bioelectrolyte into solar energy, this is possible. Then microhydel also, I told already about the hydraulic plant, the turbine. Then WHR is the waste heat recovery, and so till now we have developed some innovative products by using the research development and some ideas, and almost we are all are in prototype stage. So if we'll consider one by one, then in a food sector, we developed a millet processing machine and micro food processing machine for individual items. So millet is a very it is a forest product, like ragi, suwa, foxtail millet, and bajra. so many millets. Millets are the most proteinous food. Earlier, poor people are taking millet. Now, rich people are taking millets because earlier it was the main food of a poor man. Like tribal people are very much habituated taking millets, but nowadays they are not. Though they are cultivating millets, but they are not using millets. Because of that, because of that region, now tribal people are suffering more in diseases because they were habituated in taking the millets. Now they are not taking because rich people are taking the millet by paying higher price to and purchasing from the tribal people. Similarly, that those processing machines early days it was not available. They were using the conventional methods, and by conventional method, people process the millets. So 60% wastage are there. So to keep waste as minimum as possible, maybe 5 to 10% it is wise. It is advisable. So with 5% or 10% of wastage, we developed some millet processing machine like de-husking of quinoa, de-husking of ragi, de-husking of soa, de-husking of foxtail millet, de-husking of guruji. So all machines, either it may be a single machine or it can be integrated to get all the machines, all processing in one particular machine. You can get it also. So then environments already we have developed some membrane technology to capture CO2 and carbon dioxide from air as well as from power plant. But it is in prototype, and in a mass scale we have to do again lot of work to get it in, to bring it to industrial scale. But the initial means the first, the prototype, from the idea we developed the how carbon dioxide can be captured. So for this, how research is, how we carried out research and how we reached in this particular idea. Let me speak a few things here. See, carbon dioxide, it is membrane means it is just like a filtration type, and when any gases are coming out and flowing, there are some, the gas kinetic diameter as well as gas flow velocity is also differs. Even carbon dioxide, nitrogen oxide, even oxygen, even H2S, when they are moving all together, because of the kinetic diameter, carbon dioxide kinetic diameter is big. So it's a speed is higher. So taking those that in that knowledge into consider account, so we developed the molecules, we developed the membrane maybe it is a micromembrane, it may be nanomembrane, it may be ultrafine membrane. There are so many types of membrane are there. So taking all this knowledge into account, we developed the membrane and we put all the membrane in a different tubes and arrange all the tubes in a systematic manner. So finally we found the CO2 is getting filtered out of all the gases. So this is one of the very good item. And now if you get pure CO2, you can you can utilize those CO2 for anesthesia in medical science. You can take this CO2 for solid ice. Also you can use this CO2 for a methanol production. So this, for that also, taking this idea into account, we developed a zero emission cartridge, and for which CO2 sequestration is also required. So now let us discuss about the waste recycling. So plastic to tile and bricks, bio waste to bioenergy, enzyme and fertilizer, bio nanosensor, IS to tiles, and so many other things. Also, then clean water, waste water also we can convert to clean water by using lot of series of technology. Then same, I am continuing in innovative products. So this is in health. We have developed a immunity mobilizer. So immunity mobilizer is something new, and there are some plants also people are nowadays using, and some plants still people do not know its use. So because from the plant extraction, and when you go extracting the plant, and after extracting the plants you will get some lead compounds, that means phyto compounds or phytochemicals you can say. So there are two, one is inorganic chemicals, and another if any chemicals coming out of the plant, that is called phytochemicals. So taking those phytochemicals or phytocompounds, if you join all phytocompounds and using a method is called QPAR or QCAR also you can say, quantitative composition activity relationship. This is a computational algorithm developed by us, quantitative plant activity relationship, where you can mix all the ingredients or phytochemicals to get a desired output. So that immunity system also we worked in immunity developing system, and beside that we developed in ICU. When I was in medical hospital, high tech medical college, we developed a small instrument. So that instrument which can be used in ICU for bacteria capturing. So see, when a patient is coming to ICU, not ICU, people are coming almost when people are in critical stage, lot of people are coming. So not from one disease, with the various diseases, various different type of patients are coming. So when patients are coming to the ICU, so there is a chance of infections from patient to patient, because no single disease, because various disease people are there, so various infections are there. So there is a most chance of infection of even sometimes doctors are also getting infected. So because of this infection occurs because of various bacteria there. So I know what are the different bacteria like insomnia, and some bacteria are there which the bacteria can be captured by using a system that we developed a prototype and we filed patent for that. So in ICU it will be helpful whenever any patients are coming. The bacteria, once it will come to from the patients, either it can once it will be spread in the air, those bacteria can be captured. So that is also there. So in sustainable medicine, natural drugs also people are nowadays very much interested for natural drugs. By knowing the drawbacks of the synthetic drugs, people now coming to join in natural drug category. And in manufacturing also, manufacturing there are a lot of we are very much less in manufacturing areas, and because in India there are very less skill power persons are there. Those skill development training all the colleges or institutes are giving, and government is also spending a lot of skill money on skill development. But practically, if you can see or if you see practically, you will find actually the skill development, properly skill developments are not there. No colleges are giving proper skill development. Only people are coming and haphazardly they are doing classes. Even trainers are not that much competent to provide the skills to them. So the skill development now became a scam development. There is nowhere the skill, proper skill is given. So government, it is a wastage of money. So also here research is required. How proper skills can be imparted to each and every youth in India, so that unless people got the skill, they will not be employed. So skill is very much required for all of them. So taking those skill, no. So for that also, how skill can be imparted in a group wise to all the students or to all the youth. So for that also some research is required and innovation also, that skill tools also required. In what way the tools can be provided for different skills, those also very much required in manufacturing system. Then digital control system, digitalized system, IoT assisted agriculture, because now agriculture needs IoT assisted because to health monitoring, to soil health monitoring, and even old age monitoring for the old people. And nowadays old people are staying alone, their parents, their inwards or son, daughters, they are all staying outside of their house, and old parents are living alone, and nobody there to take care of their health. So for which they need to be, their health need to be monitored. So it is required for a remote monitoring system, and for here also health, the research is required, and from the research you will find innovations and how the kits can be developed by taking research. So this is one of the aspects where it can work. The next is so these are already I described. So some of the products, whatever product we developed, I am showing here. This is a smokeless stove, and this one is the pellets. Pellets we are getting from agro waste. Straw, after taking the paddy out of the straw, those straw we are consolidating and putting some catalyst into the straw, and we are converting to pellet, and pellet we are putting in this stove, and we are getting the very means less consumption fuel. Also no smoke is coming. For cooking system it is automatic, it is electronic control also. The complete stove is electronic control, and this is an idea. This is one of our product, innovative product, I can say you. This innovative product came from the research and development, by doing research and development. So research and development is always a path to the innovation. Unless there is the research and development, there will be no innovation. So innovation from research and development, finally you will get business, but through innovation. And whatever money we are going to spend on research development, it will not be wasted. Directly you may not get any output, immediately you will not get any output, but in later on, while converting this knowledge into product, and finally you will go for business. So by doing business you will get money, but whatever money you have spent during research and development, you will get huge amount of money compared to this spending on the research and development. So this is one of the product, and we are also working on this, and we are now we want to sell it, and even in Koraput also one NGO came and took hundreds of our stoves to supply to the tribal area. Thus we started this. So this is one of the problem. I think you might be heard about Haryana, Punjab, and Uttarakhand, even in Uttar Pradesh also, Bihar, even Odisha also nowadays, people are going for stubble burning. Stubble burning means whatever cultivations are after harvesting, they are putting in the straw and other items like the agro waste. Not only in case of paddy it is straw. In case of other agriculture product, they are also putting all waste into their land, and when it is getting dried, they are putting matchstick on that, and this is burning. So you do not know during the burning and how much soil is getting deteriorated. So 6 centimeter, sorry, 6 inch of the soil is getting heated. So because of the heating of the 6 inches of soil, all the microorganisms present in that soil will get destroyed. Again, to create microorganisms, farmers are putting manures like a gobar and means what is fertilizers are there spending on that. So by fertilizers also costs more, and once it is getting heated after firing, because of the farmers are losing many things which they do not know. So nowadays government is, so that is one problem. Second problem also, it creates environment pollution. When Punjab they are burning, they are going for stubble burning, and Haryana they are stubble burning. By that time the smoke is going to Delhi. Sometimes it is creating problem in flight landing and flight lifting. So government tried to stop them, but still till today also there is no system developed, and still the stubble burning is going on. And though government is trying to convert the straw into ethanol plant, in Bargad also Indian Oil Corporation started an ethanol plant, but that ethanol plant is not sustainable. Why? Because the production cost of ethanol and the selling cost of ethanol, unless government gives subsidy, then this unity will not be viable at all. Means production cost is higher, selling cost is lower. So there is a gap. So government, so long government will give subsidy, this will run. Once government stops subsidy, this will fail. Okay, so these are some of the things we are working to utilize those straw into pellet, and finally pellet we are taking to the furnace or to the stove for biomass stove or combustion purpose. So these are the some business model we developed, and this business model developed by doing marketing research. So everywhere research is required. Even in social research, technical research, marketing research, even in some environmental research, chemical research, everywhere research is required. Without research, we cannot proceed even a single step. So from all the research, you will get some idea, and finally from the idea you will get a product, and where your livelihood and where your life will be comfortable. This pellet machine we have developed, and some of the different type of pellet machine we have developed, and different sizes of the pellets we have also developed. And these are the food we are cooking from our own stove. Next. This you see from a stove how a roti is while seking it is looking like a sphere. Very good preparation of food can be obtained using this food, and all type of food you can cook in this system. And this is a single burner stove, and this also you can use earthen pot, and you can cook rice as well as dal using earthen pot, so that the taste of earthen pot will be very much tasty, like Puri Jagannath temple, the prasad. You will find not Jagannath prasad exactly, not taste of Jagannath prasad, because Jagannath Mahaprabhu taste is something different. Here you will get at least a very good taste, because it can be cooked in using earthen pot. This is a 2 burner stove, double burner stove, and you can use this pellet also for cooking both sides, this side rice, that side dal, and very quickly within half an hour you can cook both rice and dal, even curry also. These are the systems. This is a nano stove, biomass stove, which we are using very small one, small one, and it is filed for World Book of Guinness Book of Dictionary. It is the smallest stove in the world, and you can, though it is the smallest, you can take it for bigger vessels. You can put over that, and heat is very high heat. At least you will get 1700 degree temperature. Flame temperature will be 1700 degrees centigrade, and yeah, this is like I was talking about organic carbon or charcoal. Organic carbon or charcoal. Here we made a reactor. It is a batch-wise reactor. Even we have developed also continuous reactor for charcoal making or organic carbon making. So you see how the gases are coming. This gas is sign gas. People put a matchstick and the gas will burn. And here also you can find on a vessel some oil is getting extracted. So these are the bio oil, and this side is the reactor is there. So this prototype also we developed. Now we are going for a industrial scale production where you can sell or anybody can, if anybody is interested, they can make a charcoal out of the any type of biomass, whether it is leaf, grass, or any type of dry biomass. It will bring, you can convert to charcoal, and same charcoal you can put on the soil, even for a rooftop garden. You can use this charcoal and convert the soil into organic. This is the biochar of the research of the biochar. In biochar, how it can be, this is a research. The tree gives a complete research on the biochar, and this how it can give benefit to the soil, benefit to the plant, benefit to the fruits, flowers, everywhere. And once you will put biochar, because of the porosity of the biochar, it can capture oil, it can capture water from the atmosphere, and it will make it will increase retentivity of water more, so that the tree can grow easily and the growth of tree will be more. Next. So this is a particular catalytic based biomass plant we developed. Here also we put some type of catalyst. You can see here this one. So in port side, 4 catalysts are there. So already we started this, and up to 50 kilowatt power plant can be generated in a village if we can use the biomass and generate a power out of biomass. And this is a particular type of system where you can go for supercritical power plant. Supercritical, nowadays government is also emphasizing to NTPC, go for supercritical power plant. Supercritical power plant means temperature must be more than 1000 degrees centigrade, and now the temperature is 500 to 600 degree temperature, and pressure should be more than 100 kg per hour, 100 kg per centimeter square. Pressure of the steam and temperature should be 1000 degrees centigrade. And for supercritical power plant, the consumption of fuel will be very less and more power will be generated, and minimum one power plant should be minimum at least for 1000 megawatt. So already 2 supercritical thermal power plants started, in one in Madhya Pradesh and second one in Rajasthan, I hope, but I don't know, I forgot. But in Madhya Pradesh, already one supercritical power plant government NTPC developed by using coal. But in using biomass also supercritical power plant can be possible. Next. So this is something dye sensitized solar cell, and this also this is possible. And for non-ferrous welding, we can use hydrogen or hydrogen oxygen fuel for making non-ferrous welding, and this particular microhydral power plant waterfall used in waterfall, and from waterfall you can generate electricity. And next, these are the millet prototype of millet de-husking machines. This is a millet de-husking machine of Sua, and next one it is coming ragi. Next, this is for ragi, de-husking machine of ragi. Ragi is a very interesting grain or millet where the cover of ragi is especially cover of ragi is very thin, and maybe it may be nearly 1 micron. So, and ragi shape is, though it is not completely spherical, but removing 1 micron cover husk from ragi is difficult. So, but anyhow, this we developed by using a technique, and now we are in process of developing this de-husking machine in a commercial way, and agriculture department already they have given instruction to us to develop and to collaborate with them. So now it is under process. This is quinoa. Quinoa actually a South American grain, but quinoa is having a protein, high protein, maybe 18 to 19% protein. It's the highest protein all over, like whatever food we are taking, agriculture based food, all the millets, all the rice, wheat, etc. Even the protein percentage in case of quinoa is more. So nearly it is coming 18%. But quinoa is it is not completely spherical. Its cover is very hard, and size also quinoa is very small. It is smaller than the mustard size. Mustard is spherical completely, but it is not spherical. But the same problem people are facing in South America. Also, when I went to USA and we discussed about this process, and I presented over there how the processing can be done, and they are using earlier we are using dinky, so same type of thing they are using, and where the wastage are coming very high, and the quinoa cost is also very high. The wastage maybe 60%. So this way you will get 10 to 15% wastage are there. So you can process quinoa by using this machine, and the machine principle is here. It is abrasive de-hulling machine. Then preservative. So let us come to the preservative. Nowadays, whatever drinks available in fridge, available in shops, and all drinks there people are adding, whether it is a Coca-Cola or fruit what is that? Mango juice or appy, means apple juice or orange juice, whatever it may be. They are adding sodium benzoate to those juice, which can store preserve this juice for a period of 6 months. But sodium benzoate is a chemical. Though it is used in juice, but it is a chemical. It is not good for health. So for which organic preservative is required. So in organic preservative, there are some compounds. Let me explain one of the compound that is called flavonoid. So please remember, it is a flavonoid, is a organic compound, comes from plants. If you extract flavonoid and keep it in a store it and mix in all the juices, then you will get preservative. You need not require sodium benzoate to mix with the fruit juice. So we extracted the flavonoid and developed the preservative and took a trial, but still it is for a small production. For a mass production, it needs again the machines should be in an industrial scale. Unless we do in an industrial scale, it will not give any profit. So initial for any prototype development, lot of expenditures are required. And using prototype, you cannot go for commercialize because it will create a loss in your business. So to make it a business, first you have to make it industrial scale. You have to scale it up. Then after coming to the industrial scale, you can go for a business. Next. So this is a artificial honey we produced, and this is the first world's organic red wine we developed from Mahua. So this is we did not do any fermentation process for any type of wine. While making, the process is used fermentation, for which it took nearly 60 days. So within 60 days, you have to go for two types of fermentation. First, primary fermentation, which took 21 days, then secondary fermentation, another 21 days it will take. So, but here we have done molecular extraction process. This is a new type of and we have filed for a trade secret. This is wine, and this also requires research. Without research, you can't develop any product or any innovation unless you do research or unless you be educated in that particular field. Means completely educated, then only you can develop any idea and you can produce the research, some items. So this is red wine after molecular processing of Mahua, only 100% organic, because Mahua by default itself, it's organic. By default itself, it is organic. So in a grape also people are making wine. In other fruits also people are making wine. But in that case, they are using fermentation process. But grape, yearly people are giving 6 times pesticide to the grapes. 6 times. In a year, throughout the year, people are putting 6 times pesticide on the grapes. So grape is not organic at all. But why here Mahua is organic? Because it is coming from the forest. Forest, you know, people are not using any inorganic substance. So Mahua, you can say it is by default it is organic. Next. This is a filter. We have used those silver nanoparticles and developed an alkaline filter. For a health purpose, we need alkaline water, not acidic water. In most of the cases, you will find in tap water it is acidic water. But acidic water will create a problem like acidity, and sometimes if it goes heavily, then it may create some cancer cells in the body. So always alkaline water is desirable to drink. So we have developed one alkaline water filter, and here we are using silver nanoparticle in the candle. No electricity is required for this, and this also we developed. This is not prototype. This is final product, but developing this, we need some instruments for going for mass production. So I told you that about the carbon dioxide capture. Nanomembrane, micromembrane, ultrafine membrane are required, for which you can separate any gas, not only carbon dioxide, any type of a gas you can separate from mixed gas. It may be sulfur dioxide, it may be hydrogen sulfide, it may be carbon monoxide, it may be oxygen, it may be nitrogen. Any type of gas you can separate, but for separating gases, you need to require to put some membrane separation. So these two, those are the porous catalytic cartridge, and here carbon, activated carbon and cellular acetate membrane we are using, but both membranes are in the holes are in nano shape. So using this, you can get carbon dioxide capture. You can separate it and store it in a separate vessel for further utilization. So this is another in building material. So fly ash, you see, you can, lot of fly ash wastages are there in thermal power plant, because in thermal power plant you will find a huge amount of fly ash. They are dumping in like a hill, and sometimes they are putting fly ash in the river, and so those fly ash now people are using for brick purposes, and also people can use it for tile purposes, because whatever tile we are using in our house for making roof smooth, so fly ash, from the fly ash we can convert fly ash into tiles. Already we developed the technology, and we tested in Gujarat. There is a Morbi, one place is there where Asia's largest tile hubs are there in Gujarat, Morbi. It is near to Rajkot. We have taken our all materials and tested there, and we found and we converted all the ashes into the tiles. Tiles they are this high strength. We are achieving high strength also, and in later on also this particular fly ash waste is people are now very much fed up with this fly ash waste. So this tile can be manufactured from the fly ash, and wastage can be utilized. This is plastic tabletop, and fibers also we put natural fibers on this tabletop plastic, and you'll get a very good strength. Natural fiber means pineapple fiber, any tree fiber, anything you can put. And by using those fibers, if you put in a plastic, then you will get enormous strength. Strength-wise, it is unbreakable. No, I cannot say it is breakable, but it requires high amount of energy to break it. This is this I developed. It is a nanotechnology based piston, also which requires nanoscience, research in nano science to develop this type of product, because pistons, whatever used in scooter, motorcycle, even car, truck, whatever it may be, people are using aluminum alloys. So if you put some nanoparticles, either silicon carbide or alumina nanoparticle, and mix with the aluminum, then by taking all this and casting it and cast it, then whatever product you will get, it is very, and its thermal conductivity, thermal boiling means thermal expansion, everything you will get good properties. Even mechanical strength also will get very property. Already this product also, the right side product is the escort piston, the left side product piston developed by nano piston. It is we worked on Nalco project, and we have given this piston to Nalco, and by taking their materials from aluminum, this is Nalco aluminum and Nalco alumina. Nalco is producing both aluminum and alumina. So both material we have taken together, then produced this piston, and This piston we tested also, compared to the escort piston, it gives 2.5 times more strength. Thermal resistance is also more. Fatigue resistance is also more. These are some of the products using nanotechnology. This is, I told you, water filter I have shown you. This is nano water filter, alkaline, to filter, to get alkaline water. This is nano tiles also. We have put some nanoparticles in the inclusion. And this is nano body lotion. Body lotion, face lotion, this piston, nano face lotion, nano cream also. See, this is for arthritis. Arthritis patients people are using instead of taking injection on the knee. So they are creating nano graphite particles and mixing with the hyaluronic acid and getting the nano arthritis scheme. And after doing massage on the knee or any joint, gradually the graphite particles are entering into the joint of the body, or joint of the leg, or whatever, wherever you are going to put cream, in that particular joint it will enter. So then finally you will get, the patient will get cure. The clinical trial is now on, it is under process. This is a porous fly ash brick. Porous fly ash brick we have not developed, but it is already developed. And even in Odisha there are two porous fly ash bricks are there, where 80% fly ash people are using in that industry. But there is a problem in that particular industry, because after making this brick, for curing purpose they are using steam they are using. So for spraying steam for a period of 6 hours to cure it, it takes, the money consumption is huge. That's why the production cost of particular this type of brick increases, for which they are now seeking the alternative method of curing. So we developed a curing method for them. So that we are going to implement in Runta mines. Sorry, not Runta mines. Sorry, Runta. The person name is Runta, but the industry is located in Tangi, Katak Tangi. It is located. So from Kapilas Road to right side, while going from Bhubaneswar to Katak, that Balasore, or Katak to Balasore, you find a right side there is a factory. Now, because of this cost, they are going to close this factory. No, we told, no, don't close, but they will give you an alternative technique for which you can cure this fly ash brick. This is already shown. This is the clay tiles shown. This is a curing system for any type of concrete, fly ash brick, fly ash whatever, porous brick, or any type of curing system. We can use this particular. This is also the vacuum technology applied here, and the curing, you don't need any single drop of water, because do you know how much water people are wasting during the preparation of during the construction of building? While constructing the building, even brick wall is getting to be cured, even concrete pillar to be cured, roof to be cured. Each item should be cured by using water for a period of 21 days. So 21 days, you have to dip the complete structure into water. Think how much water is getting consumed every day. So if you can calculate this much water, it will be huge. We do not have its quantity right now, but this can also be solved by using a vacuum technology process. But still it requires an industrial process, and for which we are also trying to be involved to develop the industrial process. And so I think it is the this is not required for, this is for blind people, and for this is not required. Next. No, this is not required. Not required. Oh yeah, that's not. No, no, not. Okay, thank you. Actually, let me say something. So research is the vital part of any system. So system may be anything else, but without research, it's not possible to go for innovation. And you will find if you will see the India status, our the file of patent is very less. It may be 100 times lesser than the China. Even Taiwan also it is lesser. Even compared to our position, maybe I don't know exactly, I forgot. So maybe 10, 15 we are in that position. So research is very much required. So even fundamental research is required. Though government is not giving any emphasis on fundamental research nowadays, because since 1947, India is doing fundamental research only. Only fundamental research, fundamental research, fundamental research. Every time fundamental research. Now government is imposing you go for application research. Application research, you develop something. You developed something which can be immediately useful for a human being. So whatever fundamental research is there, because already research is there, and literature is also there. So people should go for literature and find the applied, which how the literature, how this research can be useful for application. So unless people applied this fundamental research in applied research, nothing, no output will come. So we have to keep target on output. It should be output or outcome based research. So outcome based research is nothing but the innovation and a business. So unless innovation is there, the India cannot proceed much. So we should not think about the India next generation and next within 20, 30 years India will be superpower. That will be kept as a our dream. So with this, thank you very much. If any question, I'll be able to answer you. Hello.
Thank you, sir.
Any questions? Because I thought beginning I thought to generalize the research development path to innovation. But when I think when we have developed, when we have done something, some innovation came from research. So those research, out of research,
Exactly,
whatever ideas. So I thought let us show some case study to before the participant, so that they will be interested for research, as well as from the research they can go for innovation, product idea, then innovation to commercialization.
Definitely, sir. Actually, your presentation was so nice and helpful, and you have presented actually what you have developed or what actually the society needs. Thank you, sir. Now I'm requesting Mr. Prithibas Kuntia, Assistant Professor, Mechanical Engineering Department, to present vote of thanks.
Thank you, sir.
Okay, but before vote of thanks, let me ask if anybody is having any questions about the whatever I showed. If you question, I can, because I think before time I finish. So
No,
if
sir.
you question,
Actually, sir, actually we have finished within the schedule. So actually, whatever the questions from our audience,
Ah.
so, I think in the chat box there is not a single question. That if they will, they have any question.
okay, if there is
they
no
will,
question,
their question. Will,
okay, no problem. Okay, let us finish.
thank you, sir. Sir, please.
I, Sri Krithivas Kuntia, on behalf of Synergy Institute of Technology and the entire fraternity of the institution, first of all, extend my most sincere thanks to the Almighty God for making today's event sounding.
Just for 1 minute.
We are able to make this event what it was. Institution, I extend a really hearty vote of thanks to our keynote speakers, Professor Dr. Kamalakanta Mahapatra in the first session and Professor Dr. Padi in the second session, who spared their time from his busiest schedule to grace the occasion. Today, we had an opportunity to hear your thoughts in particular experience, and this will surely be going to encourage us in our future events. I am immensely thankful to our Honorable Chairman Vinod sir for his continuous pampering towards this kind of events to conduct. I would like to give my honest sense of appreciation to our revered director, Professor Chitrasen Jagaddev sir, for his unstoppable nourishment for conduction of this kind of extracurricular activities. I also extend thanks to our respected principal madam, Professor Dr. Jogeshwari Raut, for being the catalyst towards the disciplined accomplishment of this event. I am immensely thankful to our beloved HOD, IIC President, Professor Dr. Rameshchandra Naik sir, for his week-long perspiration towards the controlled conduction of this event. I need to mention my deepest sense of appreciation to all the staff members for their enormous cooperation within the event. I would also like to thank all the participants, students who patiently hear and boost the spirit of this event. In a nutshell, I would like to give my heartful regards to all the members who have spared their valuable time to make this event significant. Thank you all. Jai Jagannath.
Thank you, sir. Uh, Thank you. Now,
बंद कर दिया? क्या बोल रहा है?
जो ऑयल के बारे में बता रहे थे, यूजिंग ऑफ ऑयल, ऑर्गेनिक ऑयल, तो ऑयल मैन्युफैक्चर बाय